Hey guys, let's solve this question. This question is of based on discrete math and it's of gate 9090. So we need to find all WFF formula which are valid. So before solving this question, you need to know what are WFF, right? So I wrote few property of WFF that will help you to solve this question, right? So the first point is any WFF, they are either true or false. Like any expression that is either true, so that is WFF. Any expression that is false, that is WFF, right? So it can be true, it can be either false, right? This is my first point. The second point says any prepositional variable is a WFF, right? So let's say my prepositional variable is P. So P can be either true or false, right? So as I said, using property number one, any expression that is either true or false is a WFF. So any prepositional logic that is, any prepositional variable such that A and B like just exist, so that is WFF, right? This is my second point. The third point says that if somehow my P is WFF, then negation of P will be WFF too, right? If let's say P is true, then negation P would be false. So this matches your first point. They're either true or false, right? So this is my third point. The fourth point says that if somehow P and Q are two WFF, right? Then any possible combination of their formula such that P NOR, NAND, uh, implication, XOR, that will be WFF2, right? This is my first, second, third, fourth, and the last and the most important point is that after simplifying that expression, it should be a tautology, right? It should be a tautology. You have to just remember this, right? So let's say it's if somehow my final expression give me a value true, comma one, it would be that following expression would be my WFF, right? Yeah. And at last, there is a note. If somehow you get this expression, let me write it here. If somehow you just get an expression like this, if P negation P and Q, if somehow you will get this expression, this is not a WFF. It's not a WFF, right? Since we didn't know negation is either P or P and Q, so there is an ambiguity between. So it's not a WFF, right? Yeah. So the first point was they can be either true or false, right? The second point was they are like any proposition logic, any proposition variable are WFF, right? The third point says that if P is a WFF, then negation of P is also a WFF. And the fourth point is P and Q are WFF, then any possible combination of their formula are WFF2, right? And the last and most important point, the final expression should be a tautology, right? Now let's solve this question. So answer can be any of the following A, B, C, D, right? So you should know A implication B is nothing. It's equivalent to A bar plus B, right? You should know this. Now using this property, let's solve this question. So it would be P bar plus Q and Q bar plus R whole negation plus P bar plus R, right? I converted that following expression in Boolean algebra, right? Now that I'll simplify it, so it will give me P dot Q bar plus Q dot R bar plus P bar plus R, right? So P dot Q bar plus P bar plus R plus Q dot R bar. Now you have to simplify this. There is a property, let's say, let me write it. A plus A bar B is nothing, it's A plus B. So you have to remember this property for solving this question, right? Although you can derive it, but you should remember it, right? So using this property, our final expression would look like P bar plus Q bar plus R plus Q. Since we got this pair, so it will give us 1 plus anything, that would be 1. Since one is a tautology, so our sorry, the option number A is our final answer, right? Since we have single correct answer, we got in a first try or A answer. You could try with all of them. Although you can just judge this option. Since this is not a WFF, because they didn't specify negation with either P or P implication negation Q. So they didn't specify. So this answer is wrong. Here too, they didn't specify either negation with either P or the whole expression. So this is also wrong. And now you can check up this expression too, right? Yeah. So thank you.